Good morning, students. We will today do some questions about electrochemistry. Okay. Look, what is electrochemistry? Electrochemistry deals with the conversion of the electrical energy to chemical energy and chemical energy into electrical energy. And we have mainly studying about here what is known as electrolysis, Faraday's laws of electrolysis, and then electrode potential, and if I take electrode potential and also Nernst equation. Today in this class we will be concentrating on electrolysis, Faraday's laws and the Nernst equation and the electrode potential. Okay. Now quickly to recapitulate for you, what is the Faraday's first law? Now let me tell you what is Faraday's first law. So Faraday's first law states that the mass of the substance liberated or deposited at an electrode is directly proportional to the quantity of the electricity passed. If that's the case, what's the formula? Do you remember? So formula is given by W is equal to Z I into T, where Z is known as electrochemical equivalent, and electrochemical equivalent Z itself is given by equivalent mass divided by 96,500 coulombs, where equivalent mass of the substances are given by the atomic mass divided by the valency. In the same way, Faraday's law of electrolysis, the second law, states that whenever the same quantity of electricity is passed through two different electrolytic solutions, the quantity of the substance liberated or deposited at the electrode is directly proportional to their equivalent masses. In the same way, now how can we write down the formula for the Faraday's second law? That is W1 by E1 is equal to W2 by E2, where W1, W2 are the substances liberated or deposited at the electrodes, and E1 and E2 happens to be the equivalent masses of the substances. Today mainly we will be concentrating on the problem working on these two problems. And also from the Faraday's law we know that whenever we pass 1 Faraday of electricity through any of the electrolytic solution, let me repeat, whenever we pass 1 Faraday of current through any electrolytic solution, it will either deposit or liberate one equivalent of the substance. It will either deposit or liberate one equivalent of the substance. Anyway, let us see in the problem working, how can I apply this? Let me repeat, whenever 1 Faraday of electricity is passed through any electrolytic solution, it gives me one equivalent of the substance. Of course, 1 Faraday is equal to the charge on the 1 mole of electrons, which itself will be equal to 96,500 coulombs. 96,500 coulombs. Fine, done. Now in the same way, how to define electrode potential? Electrode potential is the potential generated or developed whenever a metal is dipped in its own solution. Let me repeat, electrode potential. Electrode potential is the potential developed whenever a metal is dipped in its own solution. We call standard electrode potential when the metal is dipped in 1 molar solution of its own under standard conditions.